Okay, 12.2, we are looking at arithmetic sequences and series. So a sequence is when we are adding a fixed number to each term. So arithmetic means we're adding or subtracting a fixed number. It can be also called an arithmetic or arithmetic progression. The fixed number that you are adding is going to be called the common difference. And then this is going to be indicated by the letter lowercase d. An example of an arithmetic sequence, 5, 9, 13, and 17, we notice that we are adding 4 every time we're doing this to get to our next term. So that is an example of an arithmetic sequence because you are adding or subtracting, not multiplying or dividing, to get to your next term. The nth term of the arithmetic sequence, that is going to be your parent formula for finding the terms in an arithmetic sequence. So you have a sub n equals a sub 1 plus n minus 1d. So we're going to need to memorize that and know how to use it. So let's look at an example of using this. So here you have find a sub 13 and a sub n for the arithmetic sequence, -3, 1, 5, 9. So first thing we want to do here is find a sub 1 and d. So a sub 1 can be found just by looking at the problem, -3, first term. D, let's see, what are we adding each time? And it looks like we're adding 4 each time. Then what we want to do is we want to start here to find a sub n. So we're going to plug these numbers into the formula above. So you have a sub 1, -3, plus, then you grab n minus 1 times your d of 4. And you don't want to leave it just like that. You are going to want to multiply this out. So this is going to be -3 plus, let's see here, 4 times n, 4n, minus 4. And then -3 minus 4 is going to give me a -7. So I'm going to say 4n minus 7 is going to be my formula. So my a sub n, 4n minus 7. Now I can find any term in this sequence. So instead of writing this out 13 times and adding 4 each time, I can actually just plug 13 into my problem. So I could say a sub 13 is going to be 4 times 13 minus 7. So let's see what that is. 4 times 13 is 52 minus 7. That's going to give me 45. Okay, so that's a simple way to use the formula. There's a couple other ways that we can use this formula here. Let's look at example 2. We want to find a sub 18 and a sub n, but we're only going to be given the second term and the third term here. But this isn't going to be too bad because what we can do here is we can say this. Okay, we've got a first term. We don't know what it is, but we do know that a sub 2 is 9 and a sub 3 is 15. So we can find that common difference here. I added, because it's telling me it's arithmetic, so I know it's just going to be a common difference, I added 6. So if I added 6, well, what plus 6 would give me 9? So that first term there is going to be 3. That's going to be my a sub 1. And then we found that difference, which was 6. So then we can go ahead and plug that in to find our a sub n. So we can say a sub n equals our a sub 1, 3, plus n minus 1 times 6. And then we'll work that out. So 3 plus 6n minus 6. So it's going to be a sub n equals 6n, 3 minus 6, minus 3. And then we want to find the 18th term. So we'll go a sub 18 equals 6 times 18 minus 3. So 6 times 18, 108 minus 3, 105. Okay, next what we have are the sums of terms of an arithmetic sequence. Okay, so here you have, if an arithmetic sequence has first term a sub 1, common difference d, then here are your terms. So the sum of a certain number of numbers is how many numbers you're doing, divided by 2, and then a sub 1 plus a sub n, where a sub n is the last number. So it's first number plus the last number. Okay, so for example, find the sum of the first 60 positive integers in just this 1, 2, 3, 4, all the way to 60. So a sub 1 is 1, a sub 60 is 60, which means you're doing the sum of the first 60 numbers is 60 divided by 2, first term 1, last term 60. Okay, so it's a quick way to do kind of like bar math in your head. Hey, what's 1,000? Just 1,000 to 1, add it all together, kind of like that. So this is 30 times 61, 1,830. So if I wanted to do 1 through 1,000, same thing. 1,000 divided by 2 times 1,001, which would give me, oops, I didn't multiply it, 500,000, 500. Oh, I think that was the next, sorry. The next one, 500,000, 500. Okay, we can also do this with formulas here. So here's our summation formula. We have find the sum of the first term through the 10th term. So 1 through 10 with this formula here. So we don't have to find all 10 terms and then add them. You could if you wanted, but that would kind of be a waste of time. We need the first term and we need the 10th term in order to do this. Okay, so we would have the sum of our first 10 terms, because it's 1 through 10, would be 10 over 2 and then divided by a sub 1 or times a sub 1 plus a sub 10. So let's go ahead and find those. A sub 1 is going to be 4 times 1 plus 8. So that's going to be 12. And a sub 10, 4 times 10, 40, plus 8, 48. So now I can do this. 10 divided by 2 is going to be 5 times 12 plus 48, which should be 60. So 5 times 60, I believe, is 300. So the sum of our first 10 numbers is 300. And that's a shortcut going through it and not finding each number and then adding them. So you want to use that summation formula. Another formula to memorize. Okay, let's look at another example here. So this one is actually a little tricky because it's giving us the sum and it's giving us the, let's see here, the 12th term, but it is not giving us the first term or the difference. So that's what we need to find here. So let's see here. The first thing we're going to do is we're going to find a sub 1. So we have to use the formulas to do this. Okay, so let's see here. We've got the formula for a sum, because we're given the sum, right, of n over 2, and then a sub 1, a sub n. Okay, so I know some things about here. I know it's the sum of 12 numbers is 106. So the sum of 12 numbers is negative 106. I also know that that n is 12. I don't know a sub 1, but I also know a sub n because the a sub 12 is negative 19. So this is minus 19 here. Okay, so I get all the information I need. I've got my a sub n, okay, which is my a sub 12 is negative 19. It's the sum of 12 numbers. That gives you your n, and your sum is negative 106. So here now we can solve for a sub 1. So we've got, let's see here, negative 106 equals 6 times a sub 1 minus 19. So let's distribute that. So you got 6 a sub 1. 6 times negative 19. It's going to give you a negative 114. And then we'll add 114 to both sides. And let's see what we get here. Negative 106 plus 114, 8. So we get 8 equals 6. A sub 1 divided by 6. It's going to give us 8 over 6, which I believe should be 4/3. All right, so we have 4/3. Now we need to find the common difference. So the formula with a difference is going to be this one here. A sub n equals a sub 1 plus n minus 1 d. So we know a sub 1, and we also know a 12th term. So we can use this to find our difference. So our 12th term is negative 19. So a sub 12 is negative 19. We'll plug that in. A sub 1 is 4/3. This is the 12th term, so this n would be 12 minus 1, and then there's our d. So we can go ahead and find this. This is 12 minus 1, 11. So we've got negative 19 equals 4/3 plus 11d. And let's see, we'll go ahead and subtract 4/3 from both sides. All right, so we'll do this in our calculator now. So we've got negative 19 minus 4/3. We want to put that in parentheses, 4 divided by 3. That is going to give us this decimal here, so I'll leave it right there for right now. So negative 20.3, repeating, equals 11d, and then we will divide by 11. So let's see here. Divided by 11. Okay, we get negative 1.848. Let's put that as a fraction. Math, enter, enter. Negative 61 over 33. And that's going to be our common difference. And then if we can just go ahead and check that with the 12th number here, we've got, let's see, a sub 1 is 4/3. So 4/3 plus, let's see, n minus 1, so 11 times our answer. That should give us negative 19. So we just want to check that to make sure it works back in the arithmetic sequence formula. Okay, so here's some practice problems. Go ahead and pause the video, work on these problems, and then we will go over them. Okay, so this first example here, we have evaluate the sum of the first 15 numbers, and then here's the formula. So what we need here is we've got the sum of 15 numbers will be 15 over 2, and then we need a sub 1, and then we need a sub 15, the last term. So let's go ahead and find the first term and the 15th term. So a sub 1 is going to be 5 times 1 minus 9, so that should be negative 4. And then a sub 15 is going to be 5 times 15 minus 9, which 66. 66. So let's plug those in. So 15 divided by 2, that's 7.5. And then negative 4 plus 66. So let's see here, 7.5 times 62, 465. Okay, so the sum of the 15 numbers here, 465. All right, this next one is a little bit tricky, so let's take a look here. So find a sub 1 for arithmetic sequence having an a sub 20 of 0 and an a sub 80 of negative 120. So actually what we're going to do here is we are going to use a system of equations. All right, so we're going to use this formula here. So a sub 1 plus n minus 1 d. Okay, we do not know the d and we do not know a sub 1. So let's take a look here. We do know these terms here. So we do know that a sub 20 is 0. So a sub 20 is 0, which means 0 equals a sub 1 plus 20 minus 1 d. Right? So we would get 0 with our a sub 1 for our 20th term. We also know a sub 80 is negative 120. So we know that negative 120 is equal to a sub 1 plus 80th term minus 1d. Okay, so then this would give us 20 minus 1d, that would be 19d. So we have 0 equals a sub 1 plus 19d. This is negative 120 equals a sub 1 plus 79d. Well, we're going to use a system of equations. So let's find a sub 1 first. So I'm going to go ahead and just do this. We're going to solve for a sub 1 in this equation. Subtract the 19d. So we get negative 19d equals a sub 1. I'm going to plug that in to this equation, second equation here, for a sub 1 right here. So that's going to become a negative 19d plus 79d, and that's going to be negative 120. So let's see here, negative 19 plus 79, that's going to be 60. So negative 120 equals 60d, and it looks like our d is going to be negative 2. Okay, so we get the d. Then you can plug that back into either one of these equations. So negative 19 times negative 2 should give you a positive 38. So our a sub 1 is 38. And then just go ahead and check that, right? So a sub 20 should be 38 plus 20 minus 1 times negative 2. So sorry about that. 38 plus 19 times negative 2, let's see. 19 times negative 2 plus 38 would give us 0. So a sub 20 equals 0, and it checks out. Okay, so then this one here, find the sum of the first 10 terms of the following arithmetic sequence. A sub 4 is 7, and a sub 6 is 13. So we need a sub 1, and we need the 10th term. The easiest thing I think to do here, actually, because it's just 10 terms, is let's write it out. So sometimes it is appropriate to write them out. So we have this. We have a sub 1. So let's see here. You've got 1, 2, 3, fourth term is 7, 5, 6 term is 13, 7, 8, 9, 10. Okay, so we went up 2 things here, that was 6. So in between 6 is 2. So I think this should be up by 3, and this should be up by 3. So that would be 10, right? 7 to 10 to 13, then 16, 19, 22, 25, and then let's see here, minus 3, 4, 1, negative 2. That makes sense as a series, and it should. And then you can either add all of these together, or you can do the sum of 10 numbers, would be 10 over 2, and then negative 2 for a sub 1, 25 for a sub 3. So it would be 5 times 23. So 115. Or you could just add all of these together. And that would probably be the quickest way to do that. So sometimes it is appropriate to write out the whole sequence, but I wouldn't do it if it were more than about 15 terms. And that should be everything for 12.2.